Hello and welcome. Let us discuss about water and hydrological risks in terms of the various observations and the projections. Today in this lecture, this is the 19th lecture in series, and this makes the 4th lecture of the 4th week. So, here we are going to discuss about what are the different risks as far as the water and hydrological regimes are concerned due to the climate change. So, in this course we will see that what are the observations we already have and what are the projections. We have already discussed about the various scenarios in terms of RCPs and SSPs, and various model based projections we will try to see. So, through this we will cover these 6 1 2 3 4 5 6 7 8. So, about 7 concepts we will talk about. So, all these are different attributes of water or hydro related risks. So, friends, the first is your flooding. So, we have been receiving recurrent flooding, as we will discuss why this recurrent flooding is happening and how it is linked to climate and climate change, and with various scenarios, climate change scenarios, what will happen to the flooding scenario across the globe. The second is the risk. So, as far as the risk is concerned with respect to drought. Drought we all know with respect to meteorological drought and agricultural drought. So, here mostly we will talk about both. So, how this drought, particularly the in terms of its risk because of the water and hydro extremes are concerned. Then we will talk about the precipitation. So, the precipitation pattern varies, and because of this how the hydro or water extremes have been reported and is projected. The fourth point is evapotranspiration. Friends, all of us know about evaporation and transpiration. Okay. Evaporation is the loss of water in terms of water vapor from any surface, be it water, be it plant, be it any other barren land. But transpiration is necessarily defined as the loss of water in form of water vapor from the plant surface, and that happens through the stomata. And together, since both the processes is nothing but the loss of water in form of water vapor, they have been calculated and perceived in a together sense as evapotranspiration. So, we will see what are the changes happened or could happen with respect to evapotranspiration. The fifth is with respect to the groundwater. Most of us depend on the groundwater as far as our drinking water is concerned. So, for drinking purposes we depend on the groundwater. So, what will happen as far as the groundwater, or what are the risks involved as far as the groundwater is concerned. Further, we will move on to soil erosion and sediment load. Because of any kind of changes with respect to water and hydrological variations or change, the soil erosion and sediment loading will also be affected and will also behave differently. And then at the towards end we will try to catch them, or we will try to put them in terms of a synthesis assessment as far as the changes in the water, and we will also try to understand their consequent impacts. So, what could be the impacts if they continue to if they happen, or if means in terms of the risk, what could be the impacts on the human being, impacts on the ecosystems. And the ecosystem we are means holds the human being or the natural landscapes, everything. Okay. So, we will try to understand what could be the impacts as far as the consequences of these changes of water regimes due to the climate change. So, points what I have put here is Friends, all of us know that water related risks are projected to increase with every degree of global warming. So, with respect to the three important scenarios, the SRES, RCP and SSPs, we all have discussed it with respect to the temperature rise, and we have gone up to maximum, or we say the more pessimistic condition of 4-degree temperature rise by end of this century. So water related risks are presented or projected to increase with every degree of global warming, and more vulnerable and exposed regions, the regions which are already vulnerable and more exposed, and their people also, they are projected to face greater risks. For example, Bangladesh. Bangladesh is already living at a very low level of elevation as far as the mean sea level is concerned. Okay, so it is already in a vulnerable situation. It is the region is already exposed to a vulnerable situation. Its people are already facing the challenges. So with 1 more degree change in our projected rise in terms of global warming, or 1 degree temperature rise, so Bangladesh and similar countries will face lot of problems. Lot of coastal areas will go under inundation. So, and also similarly from the drought point of view, the regions which are already started facing the water scarcity and other things, their also problem will still be severe. They are at a more or a greater rate of risk. So, it is estimated that between 3 and 4 billion people are projected to be exposed to physical water scarcity if the temperature rise is happen by 2 degree centigrade. So, any temperature rise between 2 to 4, it will lead to a kind of exposure of 3 to 4 billion of our people in terms of physical water scarcity. So, look at the number, it is the projection. So, we are trying to understand what will be the consequence in terms of this level of warming, 2 to 4 degree of global warming will put 3 to 4 billion of people at a very high risk in terms of physical water scarcity. By end of this century, 21st century, approximately one third of the 56 large scale glaciarized catchments. So, what do we mean by this? The catchments, the river catchments which are fed by the glaciers. So, about 56 such large scale glaciers and their catchments. So, glacier induced catchments, that means their feed is mostly from the glaciers. So, about 56 large scale glaciarized catchments are projected to experience a mean annual runoff decline by 10%. So, with the most significant reductions in Central Asia. So, look at the Himalaya, the tower that we call the third pole. So, it caters, or there are a lot of glaciers there, and it is under melt and other things are happening. So, with projected temperature rise, so mean annual runoff also may decline to over 10%. So, it will lead to most significant reductions in the Central Asia. The next point is expected impacts may be felt by roughly 1.5 billion people who are projected to critically depend on the runoff from the mountains. So, if the runoff is affected, if there is a decline in the runoff, then the people who are living downstream, so it is estimated about 1.5 billion people who are depending on this runoff from this mountain, from the mountains, they will be affected. So, 1.5 billion people will be affected, particularly in terms of the Central Asia and also the the Andes. So, by end of 21st century, so by mid of 21st century, I am sorry, and this is as per the RCP 6.0 prediction scenario. By mid of this century, that is by 2050, currently we are at 2026. So, we already have crossed quarter of this century. So, by 2050, environmentally critical stream flow is projected to be affected in 40 to 79%, or you say the approximately 40 to 80% of the world's water sets. Okay, so the stream flow, which we say the critical stream flow, is going to be affected, causing negative impacts on freshwater ecosystems. Now also friend, in your vicinity, if you try to look at lot or you try to discuss with your parents or grandparents or elders, they will definitely apprise you that maybe few decades before, these streams were having lot of water or water throughout the year, or the summer season flow was really good, but these days it is almost going dry. So, this kind of feedback you will receive. So, this is what has been projected, that 40 to 80% of world's water sets will cause negative impacts, means will be affected. This will cause negative impact on the freshwater ecosystems. So, in terms of the rivers and other pond and other water bodies which you put under the freshwater ecosystem, they all will be affected. Affected means the ecosystem also means in terms of water, water is life, all of us know. So, it hosts lot of plants, animals, biota, creatures, everything. So, they all will be affected because water is life, all of us know that. Modified stream flow is also projected to affect inflows to urban storage reservoirs and increase the vulnerability of urban water services to hydrometeorological extremes. So, apart from the ecosystems, the urban storage reservoirs will affected, the urban water service will affected. So, it will affect also many countries including the developed countries. So, this is very important because the developed countries are also will be affected. So, it will not spare the water related risk, will not share or not spare between developed or underdeveloped based on the economical differentiation. It will not spare between the rich and poor, it will affect one and all. Now, let us take a look at the two sets of diagrams here, two sets of images here. The upper one is the hazard in terms of the flood water hazard, the lower one is in terms of the flood protection standard in terms of the vulnerability. And on the left hand side, figures are with respect to 1961 to 2005, that is more of an observation, and on the right hand side, based on that, the projection between 2051 to 2071 is shown in terms of the river flooding. And if you look at the legends, the legend shows in terms of the flood water and flood water protection level on this side goes from low to very high in both the cases. So, coming to an example, if you focus on a particular area, you will try to understand that how the hazard and the vulnerability things have changed, and the change may be relatively less because we are seeing it in a very small scale map, small scale image. So, coming to an example in terms of the North America, the climate related degradation and flooding of wetlands and streams in the Lumbi River watershed will negatively affect cultural practices of fishing and harvesting that rely on access to and resources obtained from the area. So, as far as the study is concerned from North America, so this kind of climate related degradation and flooding of wetlands and the streams, everything will negatively affect the cultural practices and the fishing and harvesting practices. Okay. So, the cultural and other habitats, that means will be affected because of any kind of degradation and flooding. The third one, that means the upper one, is in terms of exposure. Friends, as you know, if you focus on the lower left, the risk is a cumulative calculation or cumulative impact or consideration of these three: vulnerability and hazards, what we have seen in the previous slide, and the third one is exposure, what we are seeing on the upper row. So, vulnerability, hazards and exposure cumulatively defines the risks. So, on the upper side you can see the population distribution in terms of the exposure, and in terms of the middle row you can see the population exposure to river flooding in terms of the risk. So, as far as the risk is concerned, I would try to attract your attention to our Indian landmass and look at the lot of dots in terms of very high population density over the Indo-Gangetic region. And then when you see it in terms of the population exposed to the flooding, you will see for 2051 and 2071 India is in the top list, but you can as you can see lot of red dots over there. So, it is going to be at a very high risk as far as the population exposed to near flooding. We are regularly experiencing this for Brahmaputra river in our northeast Himalayan states, because northeast Brahmaputra, all of us know, is a dying river, and you have every year during the monsoon season lot of inundation comes because of the flooding. So, this poses lot of risk as far as the climate change induced inundation or water events is concerned. So, coming to another example in terms of Australasia, see, increasing flood events may negatively impact spawning and fishing sites of the culturally important Inaka, that is a white bait, in terms of its botanical name is Galaxias maculates, in the Waikawati river. So, one example just to quote that many of these will be affected in terms of the livelihood. So, coming to the fishing and spawning of these sites in this particular river site. So, what we take from this and the previous slide is that there are differential rate or differential influence in terms of the risk involved as far as the river flooding is concerned. Now, friends, in terms of the societal damage coming from the flood and also the drought risks. So, let us see the societal damage because of this projections are, all these projections are saying that the risk in terms of the flood, the drought and the social damages are increasing. So, let us see with respect to 6.5 RCP 6.0 and SSP 2.0 SSP 2 I am sorry, the global population exposed to extreme to exceptional total water storage drought is projected to increase from 3% to 8% over 21st century. So, an increase in terms of the water storage, okay, the extreme to exceptional will increase from 3 to 8%. So, that means you have to have artificial or man-made, or you have to put efforts for storing the water, and that will increase from 3% to 8% as far as this prediction is concerned. The societal impact. The second point, the projected increase in precipitation intensity will increase rain generated local flooding. So, as far as the means intensity of the precipitation is concerned, it will increase, and it will increase because of it will increase the rain, and this rain generated local flooding. So, immediately you will have some flash flood or local flooding, because the precipitation intensity, the pattern, everything is not yet clearly understood, and we have started receiving the precipitation in terms of what you say, a lot of precipitation in a shorter time span. We call it a kind of lot of downpouring, and also the size of the precipitation droplet is also varying, means becoming larger. So, the precipitation pattern in turn is changing in terms of cloud burst, size of the raindrop and all these things. So, that leads to a kind of flash flood or a local flooding. Direct flood damages are projected to increase by 4 to 5 times at 4 degree centigrade compared to 1.5 degree centigrade. So, at 4 degrees centigrade the global warming, by the end of the century approximately 10% of the global land area is projected to face simultaneously increase of high extreme stream flow and decreasing of low extreme stream flow. So, friends, what do we understand from here? At up to 4 degree temperature rise, so 10% global area will be affected. Somewhere this this effect will be different. Somewhere it will be high extreme stream flow, somewhere it will be low extreme stream flow, because the precipitation pattern is changing and the other conditions are also different. So, what are the other conditions? The soil condition, the forest or presence of other materials which delays in terms of the runoff and stream flow and all those things. So, everything is getting affected. So, that leads to a projection of both increase in the high extreme flow, high extreme stream flow, and also decrease in the high extreme stream flow or the low extreme stream flow. So, in either direction this can happen, and if this happens, this would affect roughly 2.1 billion people across the world. Another point is with respect to the WAS. Okay. So, water sanitation and health sector. The increase in the extreme events is projected to compromise the efficacy of the WAS services and slow the progress towards the reduction in the WAS related disease burdens. So, if this kind of the change in the precipitation, so higher, lower, different amount, different quantity, timing change, all this happens, then it will definitely affect the WAS sector including your water, sanitary and health, and also it will trigger and it will alter or it will affect a lot of diseases. Okay. So, it will change the disease burdens, okay, or it will have disease will come to us in terms of a burden which is from this sector, WAS sector. The future water related impacts of climate change on various sectors of the economy are projected to lower global GDP ranging from 0.49% of GDP by mid-century to less than 0.1% that is as per the prediction of RCP 8.5, very pessimistic, and SSP 5. So, this will affect the economy. It will lower the GDP up to 0.5, or you say in terms of the by mid-century, 1% by end of the century or so. So, with high projected losses expected in low and middle income countries. So, this in turn will affect the GDP, the income, and more so for the developed and underdeveloped, or more pinpointedly to the low and middle income holders, including the countries or the regions. And let us move on to understand the percentage, the projected percentage changes in terms of river flooding between 2071 to 2100 relative to 1970 to 2000. So, look at these three based on SSP, different SSP scenario conditions, scenarios. 2.6, we all understood that it is the pathway. 2.6, 4.5, and the lower one is the most specific pessimistic is 8.5, and this the different things as different colors represent the return period in terms of the years. So, on either direction it can move, and you can see the depictions, but more importantly, to let us take the take home message from here is the red regions are on most of the subtropical or temperate belt. If you have a look at the Western Europe and also the America and the southern tip of the South America and most of the North America, then you can find out there is the return period in terms of the river flooding is decreasing, whereas in terms of the in terms of the other regions, you focus on the rest of the part, particularly the equatorial region or the tropical region, including the upper part or the northern part of the South America, the Africa and India and this part of the southeastern landmass, you can see the return period in terms of the flood frequency is increasing. So, the tropical or equatorial regions, the return period is increasing, whereas in terms of the subtropical and temperate regions, as far as the northern America and the western Europe is concerned, it is decreasing. Now, let us try to see the current global drought risk. We have here also in the first two and the lower right, we have tried to show the drought risk in terms of hazards, the vulnerability and the exposure, and on the lower right we can see the drought risk. The drought risk is shown in terms of low to very high, and look at the over Indian subcontinent. On the western side, particularly the southwestern side, starting from the Maharashtra to downside, you can see it is at a very high risk as far as the drought is concerned, in comparison to little bit of the eastern side where we are currently located, particularly West Bengal and Chhattisgarh, MP and this part of the country. So, look at this. This gives us the different areas and under different set of drought risk conditions. So, increased water temperature could lead to shifts in the structure and composition of the species assemblage following changes in the metabolic rates and this. So, now the quality of this of the quality per component. So, if the in terms of the quantity, lot of means high or low, so that gives us a flood or a drought situation. In terms of the quality, if the temperature rise happens, so increased water temperature will lead to, because temperature rise is happening, so water temperature will also rise. So, increased water temperature will lead to shifts in the structure and composition of species assemblage. So, in terms of group of species which is staying here there, so that will also be affected. So, the effect will be in terms of their metabolic rates. So, various physical activities we do, respiration, transpiration, everything we do, so that will be affected. Body size will be affected. It will be dwarf or it will be elongated, it will be different size will be affected. The timing of migration. So, earlier let us say you want 2 months of temperature within this range, now you are getting it for 2.5 months or 1.5 months. So, accordingly the timing of migration of the species, we know the birds and others will be affected, the recruitment, the range size and all this will be affected. So, finally it will lead to destabilization of the food webs. Nearly 500 million people live in unfamiliarity wet areas, where the long term average precipitation is as high as previously seen in only about 1-6 years. Increased risk of conflict between different sectors also will arise. So, what is the conflict? You will have conflict between agriculture and industry, you will have conflict between industry and domestic. So, because the need of urban and rural is different, the need of different sector will be different in terms of water related utility. So, there will be conflict between these. So, in turn there will be it will affect to the socio-economic development, urbanization and many things. So, the effect will be cascading as far as any changes or any variation alteration of this water regime happens. So, here we try to put a kind of projected percentage changes in annual mean precipitation in terms of Asia. Also we see that there are a lot of increase in terms of future wet season rainfall. This wet season rainfall, if it is increases, then it will pose risk or increased risk of excess water runoff and potential for soil erosion, because that part of the year if you have lot of rainfall, then it will lead to lot of soil erosion. So, the soil sector will be affected, which may cause the collapse of the of many other things. So, here for an example, in terms of in terms of Asian situation, the rice cultivation or the rice terrace things will be affected. So, you can very well try to interpret all these three as far as the various level of global warming, or you say the global warming level from 1.52 degree and 4 degree centigrade. Similarly, another one is with respect to the annual maximum daily temperature, and in the similar set you can try to understand this. I will just put it through. So, projected changes in annual consecutive dry days. This is also very important, because how many consecutive dry days you get. So, consecutive dry days defines the drought, the prolonged drought phase. Prolonged drought phase, meteorological drought phase defines the risk in terms of wildfire. So, all things are linked. So, here consecutive dry days is you see is projected to be very high in terms of all these temperature rise scenario. So, it varies in terms of different percentile as far as 55th percentile, 50th and 95th percentile is concerned as far as the local things is there. So, please try to understand, and the clue to understand is that focus on Indian subcontinent, so that the situation will be more clear, and also try to maintain a disparity between the tropics or equatorial region and the mid latitude and the polar region. Things are very prominent. Similarly, let us discuss about ET, or evapotranspiration. I have already discussed about this, what do we mean by evapotranspiration, but let us see. The elevated CO2 causes stomatal closure, which decreases the ET. So, friends, as far as the little bit of photosynthesis is concerned, if we have higher amount of carbon dioxide available, which we know because of the greenhouse gases rise, the CO2 concentration have already risen from 265 to about 425 ppm over last 150 years or so. So, this higher concentration of CO2 availability will lead to stomatal closure. So, the pore, stomata is the pore which is present in the lip surface, dominantly in terms of the lower part of the lip surface, this will close. So, it closes means the photosynthesis will stop, the CO2 exchange will stop, the atmospheric CO2 will not get inside the leaf because stomata is closed. So, stomata is the gateway gateway for exchange of carbon dioxide and other things, particularly the water vapor in terms of photosynthesis and evapotranspiration. So, CO2 higher CO2 lead to closure of stomata. So, if stomata is closed, then ET or evapotranspiration also will decrease, because this much you do not need, because it is a kind of related things. So, the things will be affected. So, this is with respect to the changes in terms of evapotranspiration. Similarly, friends, the soil moisture, as we know, the various projections shows that there is a consensus in terms of the projected changes in surface soil moisture with global warming, but there are few exceptions that it may not go hand in hand. So, it is not one to one that global warming will lead to soil moisture change and surface soil moisture decrease or increase. At places we have seen decrease or increase, but the take home message from here is that there is a consensus, the agreement that projected changes will lead to what you say change in the surface moisture, so the change in the soil moisture. So, soil moisture change will decrease or increase, that depends on different set of conditions and yet fully being studied. So, coming to the likelihood of an extreme single year agricultural soil moisture drought, try to interpret this. On the right hand side, these graphs, they talk about the drier and wetter kind of situation, and the left hand side talks about the probability distribution, and the in terms of this graph. And on the in terms of the left hand side, the set of what you say world kind of situation talks about the extreme single year agricultural soil moisture drought conditions. And then we come to the understanding that we have discussed about the river flooding, drought risk, precipitation, evapotranspiration, and also this linkage with respect to the groundwater and soil erosion kind of conditions. And friends, all this will have a consequence in terms of the synthetic what is a synthetic role or cumulative role. So everything, so if one has changed, then it will lead to several changes. So you have a cumulative effect. So we have followed these references. It's from the chapter 4, and thank you very much for attending this lecture.